In this tutorial, we're going to walk you through all of the options in the moulding toolpath, where we can easily create toolpaths for mouldings that have a constant cross-section, where a 3D toolpath is created without the need to create a 3D model to ultimately give us a better finish and reduce the machining time. So let's go to File, Close. So let's go and create a new file. So working with a single-sided job, I'm going to go the width of 26 inches, height of 6 inches, material thickness is 3/4 of an inch. We'll set the Z0 position of the material surface. XY datum position will be in the lower left hand corner, and then we can press OK. Now, to create a moulding, we need a vector that represents the cross-section or the profile of the moulding that we plan to create, and then we also need a vector that represents the rail of the part that we plan to extrude the profile along. So let's start by creating the rail itself. So we're going to go into Create Vectors. I'm going to use the Draw a Polyline tool. I set my start point at x1, y1, and then I'll press Add. You can see it's been added there, and then just using my smart cursor, I'm just going to look at the length value there, and I can see we've got a length value 24 inches. I'm just going to click to accept that, and then right mouse click to come out of the polyline tool. So there we have our drive rail. Now I need to have a vector that represents the profile of the parts that I want to create. Now I've already created the profile itself, so we're going to use this option here to import vectors, and from the Moulding Toolpath project folder we're going to open the moulding profile1.eps. Open that up and we can see it highlighted there. Now with that highlighted, I'm going to use this option here just to zoom to the active view of the selected vector that we've got. And so I've deliberately engineered this to have a couple of flat areas. I'll look at various options in the Moulding Toolpath form to machine this more cleanly than if we was to just apply a finished toolpath to the overall part. So with our two vectors in place, let's just go over to the Toolpaths tab. So we're going to use this icon here to switch over to the Toolpaths tab. We'll go over to our material setup just to check over some of the settings here. Material thickness we're working with is 3/4 of an inch. XY datum position is set to the lower left hand corner. Z0, set that to the material surface. Then we move on to the model position in the material. Now we have no 3D model, so there's nothing for us to actually set here, and at no stage in this tutorial are we going to have a 3D model. Now because of the way that the Moulding Toolpath generates the toolpath, we are going to set the position of the toolpath in the material in the form itself, because in effect we are going to have a 3D object being machined in our block of material, and we'll look at that in the form itself. And check over your rapid Z gaps above the material, home start position, and then we could go ahead and press OK. So the Moulding Toolpath is represented by this icon here, so if we click on that, that will open up the Moulding Toolpath form. And the first thing that we do is select a drive rail or multiple drive rails so that you can create more than one moulding. And then the last vector that you'd select is the actual cross section. And so if we select our rail to begin with, we'll hold down Shift and then we'll go ahead and select the profile, and we can immediately see that we're presented with a preview of where the toolpath is going to be created, where we're displayed with a series of lines that represents the actual width of the moulding, which comes from the width of this cross section that we've got here. Now you can see that the moulding is hanging below the line, which is incorrect. I want it to go above the line, so what we can do is we could just look at reversing the rail. To do that, right mouse click on that rail, you'll see we're presented with the option to reverse the direction. If I click on that, that will now position that above the rail so it looks correct. You can also look at reversing the direction of the cross section. to change where the end is positioned or being hung along the rail. Now in this case I do have a symmetrical profile, so it doesn't actually matter which end we hang this profile from, but if you wanted to do that you could just right click and again use the option to reverse the direction, like so. So in the form, now we need to move on down and we need to position the toolpath within our block of material. So you can see that we've got a cut depth of 0.7 inches, and this depth is taken from the actual height of the profile, which is 0.7 inches high, and so we can position this profile within the material that we are using. We can do that by using this slider, or we could just type in precise values. In this case I'd like to position that profile all the way to the bottom of the material, so that we then have a gap above of 0.05. Next we're going to use the select button here for my main machining tool, or what we refer to as the finishing tool. So I'm going to use the select option here, open up the tool database, and I'm going to select the 1/8 inch ball nose in there, go to the default settings and press OK. Now to start with, I'm just going to uncheck all of these extra options that we've got within our form. We're just going to take a look at the basic settings here, just using a finished toolpath. So let's go to the bottom and we'll go ahead and press calculate. And then if we just twiddle the view, we can take a look at the toolpath. So it's worth noting here that this is not a 3D model, it's just a toolpath created based on the cross-section vector that we use to extrude along that rail. So if we take a look at this down the x-axis and just zoom in there, it might help if we just go to view, and we're just going to switch off the colour shaded view just so we get a better view of what the actual toolpath looks like down the x-axis there. And so you can see how it's creating that. And if we look at the ends of these curved areas here, we do get a little lift there to avoid any dwell marks, and this is all relative to the step over. And if we just twiddle that along, we can see it's just following the curve in a straight line, and it's cutting along there based on the actual step over of our tool. So if we just go to view, and we'll just put the colour shaded view back on there, and then we'll go ahead and preview that toolpath. So we'll use the preview selected toolpath option. That will just simulate that toolpath for us. And so we can see how the toolpath has been interpreted, where it took that cross section and has swept it along a straight line to create this toolpath that we can see here. So let's just reset that preview, and we're just going to switch on the visibility of that toolpath, double click the toolpath just to go back into that moulding toolpath form. So now we're going to show you how we have the ability to vary the step over on the finishing, where it will give us a better finish. So let's just zoom in at our moulding that we've got here. And so we can see that on curved areas like we have here, where we've got steep areas like this area here, because of the way that the step over is projected down the model, these will space out a little, and on angled walls where you have curves like this, this will introduce more marks, and so you could look at going in with a smaller step over. Now because this toolpath uses a profile and extrudes it along, we do have the ability to mathematically vary the step over to account for this curvature. And so if we check that option there, and if we just come down and we'll go and calculate that, and so we can see that it's tightened the step over up as it's coming over the top of the curves. And when we get to the vertical edge like we have here, it's just going to come straight down, as we're not going to work our way all the way down the vertical edge. And you can see it's got closer together as it comes over the top of those curves, and so we should see a much cleaner finish. So then we could just simply go ahead and preview that toolpath. And we can see how our part looks. So I'm going to uncheck the option to animate the preview here. I don't need that on in this example. And so the next thing that we could think about is actually roughing the part out. It's probably going to be a bit too aggressive taking the 1/8 inch ball nose to machine this out on its own. So let's just close out here, just put that in the ISO view. I'm just going to double click to go back into the moulding toolpath. And so to apply what is pretty much a roughing pass, you'd want to check this option here to use a larger area clearance tool. And so here we use the select option to select that tool. So we're going to look at a roughing tool. So typically something like a 1/4 inch end mill here. I'm just going to go the default settings and go ahead and press OK. Just going to uncheck to machine the flat regions. I'd like to apply a ramp move in here, so I'll go the distance of 1 inch, and I'll also look at adding in a very small machine allowance of 0.03, which is essentially a skin of material that will be left for the finishing tool to cut. And so once we've done that, we could just simply go ahead and press calculate. So let's just go ahead and reset that preview. You can see the software has calculated 2 toolpaths. We've got the clearance, which is practically the roughing toolpath, and then we've got the swept profile, which is essentially the finishing toolpath. I'm just going to switch that off, and we're just going to look at the clearance here. So I'm just going to zoom in there, and if we take a closer look, we can see the ramp moves here represented by the light blue as it's coming down into the part. And so if we go ahead and preview that toolpath, and what that will do is just going to essentially hog out the majority of the material with that larger tool, so that we can safely run the finished toolpath to get in at all the details. So you can see all of the different steps that we've got there. And so then we could look at the finish there, and we could preview that and see the overall finished part. And so that's the basics of using the larger area clearance to rough out the majority of the material. But there is another option that we can make use of, and that's where we can efficiently machine flat areas that we may have in our cross section. So let's just close out there. I'll just put that in the ISO view. I'm just going to double click on any one of those toolpaths, and that will reopen up the moulding toolpath form. And so in the Use Larger Area Clearance Tool section, we've got this option here to machine the flat regions. And so we'll check that, and what will happen is the software will identify any flat areas in the profile, and rather than leaving on the machine allowance in those areas, it will try and cut right down to the surface of the flat part in order to machine them during the roughing process. And so the reason that you'd want to do this is if you are using a flat tool for the roughing and it can fit into the flat areas of the design, it will essentially pocket those areas out, and then the finished tool can go back and machine the areas it needs to. So you may find it useful for the finished tool to skip the flat regions that the roughing toolpath has already accounted for. So we're going to check that option there. And so then we can come down to the bottom of the form, and then we can press calculate. And if we just go ahead and reset that preview, just undraw the swept profile so you can see the roughing toolpath here. And if you go to the swept profile, you can see it's missing out those flat areas where I've already gone in using the clearance tool. So let's just switch that back on, and then we'll just go ahead and take a look at those previews. So we'll take a look at the clearance first. So preview that one to begin with. Okay, so you can see the part, how that looks. So you can see we've got in at all of the flat areas compared to what we had before when we had that option unchecked. And then we'll take the finish profile here, we'll preview that toolpath. So again, it's missing those flat areas, and so we can see that we have a much cleaner finish in these flat areas that we've got here. And so it's more efficient, and it provides us with a much cleaner result by using the machining flat regions section. So let's just put that in the ISO view. Now, before we look at a more complex example, we just need to show you one more important variable. Now, we have the ability to apply a boundary offset so that the tool can overlap the edge of our part, and this will only happen along the edges parallel to the drive curve. So it'll be here and along the top over here. It will not overlap on the ends of our part. And so to do that, we can look at applying a boundary offset. In this case, we're going to go with a small value of 0.2. And if we just come down, we can go ahead and calculate that. And then we'll go ahead and preview that toolpath. Okay, so you can see that what's happened here, the tool has gone past the edge and it's cut all the way down to the base. And that's because we positioned the moulding to the bottom of our material block. Now, ideally, you'd probably want to cut this part out, in which case we don't really want to drop this past the edge. And an interesting thing that we can do with the moulding toolpath is to not actually include the vertical parts, or what you may have heard us refer to in the past as legs on the profile cross section. So let's just reset that preview. I'm just going to go into the 2D view here. We'll just press F to fit that to the screen. We'll take our profile and we'll just zoom in on the selected area here. And if I go into node edit mode by pressing N on the keyboard, you can see we have a leg on the left here, we've got a leg on the right here. I'm going to right click on the span and we'll use the option to delete the span, or I could press D to delete it. Go over to this span, press D on the keyboard to delete it. And I'm just going to right click to come out of node edit mode, and you can see that we now have a profile that no longer has the legs that I referred to earlier. So let's just use this option here to zoom to fit. So let's just double click on the swept profile here to open up the moulding toolpath. Okay, so taking a look at the toolpath position, we can see that we don't have as much thickness as what we had before. But what it's done is it's picked up the same gap above, 0.05 there, and it's given me the correct gap below. So I don't need to adjust this here. And this gap below will essentially be the base of the moulding that we could then look at profiling around afterwards in order for us to cut that moulding out of the block of material. So now with the boundary offset of 0.2, as the software can't see the vertical edges in our cross section, instead of going down, it's just going to extend outwards on either side of the moulding. So it's just going to extend out across. So if we go ahead and calculate that, and then if we just preview all of those toolpaths, what we should see is, if we take a look at this, what is essentially the Roughen toolpath, we can see it's not cutting through the material, so it's not going to cut all the way down, it's just going to extend out on either side of the moulding itself. So you can see that there. So you can see it hasn't cut through, but all it's done is just extended that outwards. So let's just put that in the Z view there. So it's useful to know that we can take away the vertical pieces of the profile, as we don't really need those to calculate this kind of toolpath. And so if I wanted to cut this part out, what we could do is simply extend the drive rail, and we could create a boundary vector that would essentially profile around to cut the moulding out. So let's have a look at that. So I'll just close out of the preview toolpath form, go into the 2D view. I'm just clicking the white space to deselect everything, and we're just going to click on the drive rail, click it again to put it into transform mode, holding down shift. I'm just going to drag that out just to overextend that there. Then we're going to go over into the drawing tab, and we're going to draw a rectangle, and give that a width of 24 inches, height of 4, and then we could go ahead and press create and then close. Okay, so just zoom out there. What I should have done is really positioned where this is going to be placed when we drew the rectangle in the form. That's no matter. I can take that and press F9 in the keyboard to centre that, and then press F just to fit that to our screen. We'll just switch back over to the Toolpaths tab, and then we'll just double click to go back into the swept profile there. And then we'll just come down, we'll calculate it. So just updating this, taking into account the extended drive rail that we extended there. So we'll calculate that, and then we'll just reset the preview and then preview all of those toolpaths. Okay, so you can see we're just coming out a lot more to the right and to the left. So just extended the drive rail there. So there's our part, so we could close that. I'm just going to tile the windows horizontally. I'm going to take this vector here into the profile toolpath. Cut depth, we'll put Z equals, and that will enter in the material thickness that we set for our part. Use a 1/4 inch end mill on the outside. If I wanted to, I could add tabs to hold the moulding in place. In this case, we're just going to go without tabs, and we'll calculate that. Then we could preview that toolpath and maximise the 3D view. I could double click on the waste material. You can see we've got our moulding there. So that completes this first example. So a very basic example here where we've looked at all of the different options within the moulding toolpath form. Now we're going to look at a more complex example where we'll see bigger differences in finish between existing methods and the actual moulding toolpath. So let's go to File, we'll go to Save As, and in the Moulding Toolpath Files project folder, we're going to call this one Moulding Toolpath Example 1 2.5D Toolpaths. Press Save, and you can access that from the project folder. So let's go to File, New, and here again we're working with a single-sided job. Width of this is going to be 40 inches, the height is going to be 12, material thickness that we're going to work with is 1 inch. Z0 for the material surface, XY date and position will be in the lower left. But with a very high resolution, it doesn't really matter in this case as we're not working with an actual model, so we could go ahead and press OK. So the first thing we're going to do is look at creating an arc. So we're going to use the Draw Arc option where we're going to go through 3 points. So my start point is going to be at x4, y1, and the end point is going to be 36x, 1 for y. I'm going to give that a height of 6 inches, and then we could press create, and that will create my arc for me. Close that down. Use this option here to import a vector. I'm going to import the moulding profile 2.eps file, open that up, and if we just zoom in there, we can take a look at the cross section. You can see I've got flat areas, and I also don't have a vertical leg here as I don't need them for the moulding toolpath. So let's use this option here to zoom to fit. And then we'll use this icon here to switch to the toolpaths, and we're going to go straight into the moulding toolpath. Select the rail, shift and select the cross section. Okay, so you can see how the cross section is going to be hung from that drive rail. I'm just going to right mouse click to say reverse direction so it's on the correct side there. Put a small gap above the toolpath of 0.05, so we're going to have a gap below of 0.2. Move on to our tool. Okay, so the tool that I'd like to use in this case, I'd like to use quite a large ball nose. So we're going to use the select option here. This time we're going to look at using the 1/4 inch ball nose. Okay, check over the settings. Okay, in particular the feed rate at 100, plunge rate at 30. Now this will be important in a moment as we're going to compare this to an identical piece that was modelled in Aspire. So just going to take note of those values, 130 there. Go ahead and we'll press OK. Okay, so again we want to use the large area clearance tool. We're going to machine the flat areas. We'll put in a ramp plunge move of 1 inch. Okay, and then we'll skip the flat regions, vary step over. Boundary offset, in this case we'll just go with 0.1, and then we'll just simply go ahead and press calculate. And then we could preview all of the toolpaths to take a look at the finished part. We just zoom in there, you can see we've got a real nice smooth finish. If we just switch on the visibility of the finish path, we can see that the toolpath follows the drive curve, and so it's going to create a very clean finish as it's following the curve, and it isn't trying to do a step over which isn't in sync with the shape that we are cutting. Now there is no 3D model here that it needs to be projected down onto, so the quality is going to be very good. So we can see that just by looking at our preview here. Now, how long will this take to machine? So we just put that in the ISO view, and we're just going to close this down. I'm going to come over to this icon here, the summary of all toolpaths, including estimated times. Click on that, and that will just open up our toolpath summary form. So I haven't done anything special here. I'm just going with the defaults, where we have a rapid rate of 300 inches a minute and a scale factor of 1, and we can see that the software tells us that it predicts it will cut that in 1 hour and 21 minutes. Now the other way that you could create a shape like this in the software is to either import a 3D model into VCarve, or if you are using Aspire, you could look at modelling the part using the modelling tools, and this would have required traditional roughing and finishing toolpath projected down onto the 3D model. So let's just go and open up a session of Aspire. So here is my model that I've modelled in Aspire. And if I just undraw the visibility of the toolpath, we can see that model. So I've used the modelling tools to create this 3D model of the moulding. And then when we go ahead and preview the toolpath, we'll just preview all of those toolpaths there. And if we just maximise the 3D view, we can take a look at our parts. Now, created these toolpaths using the standard 3D roughing, 3D finishing. We've used exactly the same feeds and speeds, plunge rates, and step overs that we've used in our previous example using the moulding toolpath. Now, because of the nature of the way that a traditional 3D toolpath works, we would have found a bit of choppiness where we'd have had to go back in and clean up with a smaller tool. For example, in these areas here, we might have had to come in and add a very, very small step over, which would have added more time to actually cut this out. So you can see we've got quite bad cusping here in comparison to the example that we used where we used the moulding toolpath to cut this out. So let's just close that down, and we'll just take a look at the toolpath summary using just the standard 3D roughing and 3D finishing toolpaths on the actual model itself. We can see that the total machine time here is saying that it will take around 1 hour and 27 minutes. And so if we just go back to the moulding toolpath, we can see total machine time here is 1 hour and 21 minutes. It's a little bit faster based on the prediction of the toolpath, but I believe that the moulding toolpath will cut a lot quicker, as there isn't going to be the variation of the Z where the raster pattern would be going back and forward and up and down around the part. So in this case you have a lot of 2D profiles that are being cut along, which should machine very, very fast. And so I just wanted to show you the difference in time and the actual preview quality between the two. So it's important to note here that the toolpath summary is just a prediction based on my settings. You may well be able to increase various speeds in your own setup for quicker results, or it may be slower depending on your drive motors. So let's go and save this file. So go to File, Save As, and in the project folder we're just going to call this one Moulding Toolpath Example 2 2.5D Toolpaths. Press Save, and you can access that from the project folder. So let's go and create a new file. So now we're going to look at how we can use a closed vector to use for our drive rail. So go to File, Close, we're going to create a new file. So here we're going to go the width of 40, height of 40, material thickness 1 inch, material surface for the Z0 position, XY datum position lower left, and then we could go ahead and press OK. So let's go and create our frame shape. So I'm going to start by drawing a rectangle. So in here we're going to put in a value of 30 for the width and then 26 for the height. Press create and close. I'm going to take that, press F9 to center that. I'm going to node edit mode, so using node edit function there. Right click on this span, I like to insert a midpoint so you can see that there. I'm going to take that point, this node that we've inserted into the middle of the span, and I'm just going to take it, I'm just going to nudge it up, and then I'm just going to press 4 on the keyboard and then just press enter, and that will move that up by 4 inches in the Y axis there. Then all I'm going to do here is I'm just going to right click, I'm just going to smooth that point there so you can see we've got a nice smooth top there. I'm just going to align this with that node, I want to align this one with that node there. I'll just right click to come out of node edit, right click to go back into normal selection mode. We'll take that vector, press F9 to center that, and then we could go and import that cross section that we used last time, so molding profile 2.eps, open that, and we can see it's been added into our job there. So we now have our closed vector drive rail, and we've got our cross section that we're going to use to extrude along that rail. So let's go over and switch over to the toolpaths tab. Okay, again we just want to make sure that we've got our material set up correctly. Okay, so material thickness 1 inch, XY lower left, Z0 material surface, everything else looks okay here, so I'm just going to go and press OK. And then we're going to go into the moulding toolpath, we'll select our drive rail, shift and select that cross section there. And so with a closed drive rail, our cross section will always be hung on the outside of our parts. If I use the option here to reverse the direction, you see all it does is just reverse it. My actual cross section is being hung on the outside, so that's something to always bear in mind. Okay, toolpath position, so over here we're just going to have a small gap above of 0.05, so we've got a gap below of 0.2. I'm going to use the 1/4 inch ball nose here with a 1/4 inch end mill to create the clearance pass. Machine the flat regions, skip the flat regions, we'll vary the step over. Machine allowance of 0.03, create sharp corners. I'm just going to leave that unchecked for the time being. We're going to see how the part looks with this unchecked. Boundary offset of 0.1, and then we could just simply go ahead and press calculate, and we can see the part. So you can see we've got rounded corners clearly visible here in this preview. If we just actually preview those toolpaths to see how the part looks, we can see what we've got there, and you can see we've got rounded corners here. Now if we wanted nice mitered corners, what we'd do is we'd go back into the form and we'd use that option that I highlighted earlier to create sharp corners. So if we just undo that, and we're just going to double click to go back in there, and what we're going to do is we're also going to go into the 2D view. I'm going to use this option here to create sharp corners. We'll just come down, press calculate, and you can see there that already we're displayed with nice mitered corners. So when I preview all of the toolpaths, we can see what the part will look like. Okay, so you can see there's nice sharp mitered corners there in the corner. Now you've got to be wary with this in case you have some tight internal corners, and this may cause errors with this toolpath technique. With most straightforward mouldings such as frames or mouldings that we were looking at earlier, you shouldn't really have any issues here. One other thing that we might want to do is actually swap which way the cross section is being hung from the rail. So if we just use this option here to tile the windows, and if we just double click to go back into the moulding toolpath, so you can see currently the cross section is being hung from this point. Now if I wanted that to be the other way around, where we're hanging from this side here, I'd simply right click, use this option to reverse the direction, and then we could simply press calculate, and we'll just reset that preview all the toolpaths, and we can see it's now hanging from the other side. So you may want to play around with which way you want your cross section to hang from the drive rail. So now what I'd like to do is I'd like to look at cutting the actual moulding out of the material block. So let's just close that down. I'm just going to switch over to the design tab. I'm going to take this vector here. I'm going to go into the offset tool. I'm going to offset that outwards by 4 inches. I'm going to create sharp offset corners. I'm going to offset that outwards. Close that down. With that selected, I'm going to hold down shift. We're going to select this vector here. I'm going to go back over to our toolpath tab. We're going to go into the profile toolpath here. Here we're going to cut all the way through our material, so Z equals 1 in there, 1/4 inch end mill. Going to machine on the outside of the vectors, and we'll calculate that, and then we could preview all of those toolpaths. You can see the mould in there, you can see it's done the cutout. I could double click to get rid of the waste material, and you'll see that we're now left with the actual final frame using the moulding toolpath, where we then profiled the moulding toolpath out of the material block. And so that completes this guide on how to use the moulding toolpath. As always, it's always good to save the file for good measure. So we'll go to File, Save As. In the project folder, we're going to call this one Moulding Toolpath Example 3 2.5D Toolpaths, and you can access that from the project folder.